Hey. Okay, so we're going to talk about right triangle based definitions of trig functions and cofunctions. So how is this different from what I've been talking about before? In my videos, I have been using standard position with trig functions. So I start out with a graph, and then I get this initial side here, and then I swing out usually in this direction to get a terminal side, and I get this angle theta. And so from this, I construct a right triangle with the terminal side. I choose a point on the terminal side to construct this right triangle. And then I label this side X, this side Y, and then I have to figure out what R is. So this is kind of where we've been at. But instead of using standard position to like go through all this work, we can actually just use right triangles. And so that's what we're going to talk about in this video. So the first thing I want to do is just orient ourselves with the right triangle. So here is the right triangle, ta-da. And so we're going to label the sides like this, A, B, and C. And so the important things that you need to know, the hypotenuse, what we call this side. It's very important that you know what this side is called. It's called the side opposite of A. I know it seems really obvious, but it's super, super important. And then down here, this is the side adjacent to A. So that's super important. And so if we decide to use right triangles with trig functions, one assumption we make is that we are working with an acute angle A. So A is always going to represent an acute angle when we're talking about right triangles. The difference with standard position is that we don't have to have an acute angle. So that's kind of the difference. Okay, so let's talk about the trig functions using this new right triangle definition. So just to remind you, so sine of A, this used to be y over r. The new hotness is side opposite of A over hypotenuse. For cosine of A, used to be x over r. Now it's side adjacent to A over hypotenuse. And then tangent of A, this is y over x. Now we're going to call this side opposite of A over side adjacent to A. This is pretty important. I would recommend that you actually pause the video to write these down. And then we know that these are all reciprocals, right? So we've got cosecant, secant, and cotangent. So we literally just flip all of those definitions from before. Again, super important to know this. I find that like once you get pretty familiar with these definitions, then you just remember, right, they're the reciprocal. But again, write this down. This is pretty important. Okay, so I'm going to let you in on a little secret. How everyone remembers this. I know it seems like I've thrown all this stuff at you, and you've been trying to remember y over r or r over y or whatever. The nice thing with the right triangles, everyone remembers how these definitions work using this mnemonic device. SOHCAHTOA. This is going to be your new best friend. Every class I teach, whenever we talk about trig, even like in calculus, everybody brings up SOHCAHTOA. You're going to remember this for forever. So sine equals opposite over hypotenuse. Sine equals opposite over hypotenuse. You see? Cosine equals adjacent over hypotenuse. TOA. Tangent is opposite over adjacent. If you know this, you have got your right triangle definitions. So it is a much simpler thing to remember. Let me give you a little truth bomb here. You cannot pass any trig class if you don't know this. This is super, super important to get through trig, but I think it's pretty simple to remember this definition, so that's good, but it is extremely important. Okay, so let's just do a few examples now, playing with the new definitions. So I want to find the values of sine, cosine, and tangent. You can see my right triangle, and I've got the sides labeled. So sine, like we said, opposite over hypotenuse. So the opposite side in this case is going to be 7, and the hypotenuse is going to be 15. So this is the side opposite of A. And then cosine is going to be adjacent over hypotenuse. So here's A. Here's the side that's adjacent. Here's the hypotenuse. This is going to be 12 over 15, which we can reduce to 4 over 5. And then tangent, opposite over adjacent. So opposite side over adjacent side, so 7 over 12. And so there you go. So it's pretty straightforward because a lot of times like this information is given to you as well. You don't always have to go through and like work to find the hypotenuse. Okay, so what I want you to do is just test your understanding. Maybe pause the video here. I want you to find the values of cosecant, secant, and cotangent. You've got enough information now to figure this out. So just see if you can find the other trig values. Hit play when you're ready. Okay, so cosecant of A is going to be hypotenuse over opposite. secant of A is going to be hypotenuse over adjacent, and cotangent of A is going to be adjacent over opposite side. So I'll just show you what the numerical answers come out to. So of course you're flipping everything from the previous example. Okay, so one other thing I want to talk about. Let's go back to this picture here, okay? All right, so an alternative way that we can think about this is we can label the sides A, B, and C. And if you're wondering, like, how do we decide how to label those? So notice A, it's the opposite side. So this side is the A side. Opposite of B is the B side. Opposite of C is the C side. Okay, and so now we can note some interesting things with this. Okay, so sine, remember we said it's opposite over hypotenuse. So now I want to think about what is cosine of B. So remember, cosine is adjacent over hypotenuse. So the adjacent side of B would be this A, and the hypotenuse would be C. So let's write that out. Cosine of B is A over C. All right, so this is important to note. These two things are equal. There is this relationship between them. And so there's a similar set of relationships you can also get out of tangent of A and cotangent of B and secant of A and cosecant of B. So I've got them listed here. So if you look at the triangle, and I would actually recommend that you pause the video just to convince yourself of this. You could also just deduce these relationships as well. And so these are called cofunction identities. There's a specific name for those relationships and the fact that those things were equal. So I'll just show you what they are. So there are 6 cofunction identities. So once you kind of establish like which functions are paired with one another, that's the way you remember them. So sine and cosine are paired with one another. So you just take 90 degrees minus that angle A in either case. You see what I'm saying here? And then secant and cosecant are paired together as cofunctions. So again, it's at 90 minus A in either case. So secant and cosecant go together. And then tangent and cotangent go together, and it's that same idea. So that's really the important thing to remember. And these pop up, you know, from time to time. They have kind of different applications, if you will. Okay, so one other thing, just cofunction values of complementary angles are equal. So remember, those complementary angles have to do with what sums up to 180 degrees, and so your cofunction values in that case are going to be equal. Okay, so let's just do a few examples now, playing around with this. So let's write in terms of its cofunction. So starting with sine of 10. So the cofunction of sine is cosine, so I'm just going to take 90 degrees minus 10 degrees, so I get cosine of 80 degrees. And then for cotangent, so the cofunction of cotangent is tangent, so then I just take tangent of 90 degrees minus 65 degrees, and I get tangent of 25 degrees. And then finally cosecant, so the cofunction of cosecant is secant, so maybe you want to pause here just to do this one on your own. So I have secant of 90 degrees minus 34 degrees. This will be secant of 56 degrees. Okay, and let's just talk about one other type of example. So let's find one solution for each equation. So this is kind of an interesting set of problems. I've got cosine of theta equals sine of 2 theta minus 30 degrees. So the key to note here is that these two are cofunctions. Cosine and sine are cofunctions. So what that means is that the sum of the angles has to add up to 90 degrees. So this is really, really important when solving these types of problems. So then what I can do is I can take the theta and then the 2 theta minus 30, and I can just go ahead and solve this. So in this case, I've got the theta and the 2 theta, so that becomes 3 theta minus 30 degrees equals 90 degrees, and then I can add the 30 degrees, so I get 3 theta equals 120 degrees, so theta will equal 40 degrees. There you go. Okay, and then one more. So I highly recommend that you just pause the video here and try this on your own and then hit play when you're ready. Remember, math is not a spectator sport. Okay, so I've got secant and cosecant, so these are both cotangents, or so the cofunctions of one another. And so once again, I know then this angle and this angle needs to add up to 90, right? So once we know that, we can just kind of keep going. So I've got 3 theta plus, let's see, 40 degrees equals 90 degrees. And so then what I get is 3 theta is going to equal 50 degrees. So my theta will be 50 degrees divided by 3. And if you wanted to make that a decimal, that comes out to 16.67 degrees. And if you wanted to convert that to minutes and seconds, you could keep going with that, but I'm going to omit that here for now, just for the sake of time. And so that's it for this video. If this was helpful, consider liking or leaving a comment, sharing this with some friends, or hitting the subscribe button. And otherwise, thanks for watching, guys. I'll catch you next time.